Hello friends, welcome to engineering tutorial. So in today's video we are going to take forward our discussion on the basic concepts related to computer networking and data communication. So we have already posted two videos related to that. Here we are going to, in this video we are going to have a discussion on networks. Okay, some basic concepts related to networks. Okay, so let's get started. So first let us understand the basic definition of what is a network. So a network is actually a set of devices, okay, which are called as nodes, and these devices or nodes are connected by communication links, okay, by a transmission medium. Now these communication links, it can be wires, cables, or it can be communicated or it can be connected through electromagnetic medium. So it depends what type of configuration it is, what type of communication requirements are there, that dictates what type of communication links can be used. Okay, so the devices can be a computer, desktop, laptop, smartphone, a printer, scanner, any accessories, peripheral devices associated with that. So all of these constitute the nodes, and all of these devices are connected together to form a network. Okay, so when we say network, the network in terms of area coverage, okay, geographical area coverage, there are two main categories of network. Okay, I am repeating that this is in terms of area coverage. How much of area is covered by a network? This generally falls into two main categories: the local area network and the wide area network, LAN and WAN. So the local area network, this network generally spans over a few kilometers. Okay, it basically it belongs to a single organization, such as a school or an office or a corporate enterprise or an university. Okay, it is owned by that organization, and it has a range of a few kilometers. The wide area network covers several hundred or thousand kilometers. Okay, it can operate over an entire town, city, state, a country, or even it can be as large as a continent. Okay, now we are going to discuss about local area network and wide area network in detail in a separate video. That's why I'm not going deep into these two things, because it cannot be discussed in one video. It will take one or two videos, so we are going to discuss it in a separate video. But just for you to know that there are two main categories of networks in terms of area coverage, which is the local area network and the wide area network. Apart from that, there is another category which falls in between LAN and WAN, which is the metropolitan area network, and it has an area coverage which is greater than LAN but lesser than WAN. So we'll discuss that in detail in a separate video. Next is distributed processing. So most of the networks that we come across, they use the concept of distributed processing. So what distributed processing means is that a task is divided among several computers or nodes. Instead of one device or one large computer being responsible or is given the task of operating or doing a large number of things, that task is divided into smaller chunks, and each chunk of task, okay, is allotted to a separate smaller computer units. That is what it means. Okay, just as a senior officer or the head of an organization distributes the task to his juniors, supervisors, the uh, delegates authority, okay, about various situations. Similarly, in distributed processing, a large task, okay, is first broken down into smaller chunks, and then each chunk of task is allotted to a separate smaller computer. Okay, so this is how distributed processing works. Okay, so this has many advantages. First, it is very efficient, and another thing is that it reduces the risk of network failure. It means if even one of the smaller computers encounters a failure or defect or any technical malfunction, the whole network is not shut down. Okay, the whole network keeps on operating even if one of the smaller computers undergoes any technical malfunction. But if we depend on one single large machine and it is responsible for all the tasks, if that large computer is broken down or undergoes any malfunction, in that case the whole network will be down, it will be shut down. Okay, so it reduces the risk of that situation. So that's why distributed processing is used by most of the networks that we come across. Next is the network criteria. It means that the networks, to be implemented, any particular type of network, it has to meet certain conditions, okay, in order to be used in any situation. Okay, so those conditions are performance, reliability, and security. Okay, so we are going to discuss each of them in separate. So first, network performance. So in order to measure network performance, there are certain parameters that are analyzed, and depending on those parameters, the performance of a network is evaluated. So two such parameters which evaluate network performance is transit time and response time. First, let us discuss transit time. Transit time is the amount of time required for a piece of information, data, to travel from one device to the other. Okay, it is that time interval from the instant the data packet or the information packet is traveling from one device. It can be the main server and various other devices connected to that server, or it can be an email from sent from one computer to another or many other computers. So it is that time interval, okay, the transit time. Another parameter is the response time. Now response time is the elapsed time or the time between an inquiry and a response. So what does inquiry and response means is that suppose you search for a particular information over the internet. The time interval, okay, the response time is the time interval after which the search results appear on your screen. You can understand this whole thing in that way. So response time is that, okay, you search for an information on the internet, it is the inquiry, and the search results that appear on your computer screen or a mobile screen, that is the response. Suppose you click on a particular link, it means you are performing an inquiry, and the time after which that link opens or that website opens, that is the response. So the time interval between that inquiry and response is called as the response time. Okay, so the network performance is measured in terms of transit time and response time. So the more the transit time or the more the response time, more the delay in the appearance of the search results or the response, or the more the time it takes for a data packet to travel from one device to another, the the more inefficient the system is, the network is. So transit time and response time should be as small as possible. Okay, the transit time and response time should be as small as possible. Okay, it should be quick, the response should be quick. So this is how the network performance is evaluated. Now the performance of a network, it depends on a number of factors. So the factors are the number of users, how many people are using a particular network at a particular time. Sometimes what happens is that when too many people are visiting a certain website, the response becomes slow. This happens when many people are checking on the online results for a particular exam and are visiting a certain website. Uh, you have noticed that the more the number of people visit a particular website, the slower is the response of that website. Okay, so that is how the number of users affect the performance of a network in terms of transit time and response time. Next is the type of transmission medium. Okay, transmission medium is the how the devices are connected, whether it is through electromagnetic medium or through wires or cables. The condition of the wires or cables, that affects. Next is the hardware capabilities, means the condition of the devices that are connected to form the network. Next is the software efficiency, it means the program, the coding, the software installation which is being done in each of the uh, devices. So all these factors, they affect the performance of a network. So network performance generally depends on transit time and response time. Basically it is the time for in between an inquiry and a response, and the time taken for data to reach from one point to another. Next is network reliability. Network reliability can also be evaluated in terms of two factors. First one is the accuracy of delivery, second one is the frequency of failure. So let us understand both of these terms. So accuracy of delivery means it determines how much accurate the data which you receive after an inquiry it is. Okay, so for a network to be accurate, the data transmitted should have minimum error. Okay, it should not be tampered, it should not be altered. Okay, it should be accurate as per your requirement. Okay, so that is where the accuracy of delivery, this comes into play. No missing information, no missing data. And frequency of failure, this determines how quickly a network link recovers from a failure or a shutdown. That is what frequency of failure is. So two things: first, accuracy. Okay, the data should be accurate, there should be no missing information, there should be no alteration or tampering of the data. And second is the frequency of failure, which is the recovery time of the network. Okay, how quickly the network recovers to its working state or active state after it is being shut down, or it experiences some technical malfunction. So that is what frequency of failure is. Next is network security. So network security involves protecting your sensitive and confidential data from unauthorized access. It prevents data from being damaged, altered, or modified, and it involves certain policies, rules, regulations, and procedures for data recovery in case there is any uh, breach of security, okay, or there is any loss of data, okay, data recovery. So this is what involves network security, and it is done through cryptography. So cryptography is the science or art of network security, which involves using some coded way to represent our information using something called cipher, encryption, decryption, okay. So this is what cryptography is all about, okay. So these things are just the introductory points. We are going to discuss all of these topics in detail in separate videos, but here just I am giving you a idea about the different topics that we are going to cover, okay, just to give you an understanding about the various things. So network security generally is concerned with protection of confidential and sensitive data from third party interference. It prevents data alteration, modification, and it provides us with means to recover the lost data, or in case of any breach of security over a network, and this is achieved through cryptography. So as I said, cryptography is the science and art of transforming the data, the information, into a secret form so that it is secure and immune to attacks, okay. So it uses ciphers, keys, encryption and decryption algorithms to protect the data so that it is sent from the sender to the receiver without any damage being done to it, or any theft of data takes place. So cryptography, it actually means secret writing, or a coded way of representing a message or a data. So this is all about the various network basics, the basic concepts related to network, such as network performance, network security, and network reliability, and all the associated points with it. So I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.